Live. There we go. Okay, so what is it? The 26th? Yeah, 11, 26, 19. Okay, so today we're talking about half angle formulas for sine theta over 2, cosine theta over 2, and for tangent theta over 2. Okay? Now, we've got our notes, we've got our identities, so we're going to need those. Okay? The identities I just gave you, we're going to actually use those identities to do the lesson. Okay? So, example 1. It says find the exact value of tangent of 22.5. Okay, 22.5. That's half of what number?
11.
45.
45.
Oh.
45? That's okay, Zoe, you're taking half of this. But 45 is, 22.5 is half of 45. So let me rewrite this. So let's write that as tangent of 45 degrees over 2. Right? Now we can get the tangent of 45 from the unit circle, right? Because what we want is exact answer. So if we want exact answer, you have to use the unit circle, okay? So 45 degrees is here. We got a tangent value of 1. But what we really want is 22.5, which might be here somewhere, right? 22.5. So how do we get that? Well, let's check out the formula. So first of all, I'm going to make sure theta is 45 degrees because I'm going to have theta over 2. So my formula says, all right, tangent of theta over 2 is equal to plus or minus square root of 1 minus cosine theta over 1 plus cosine theta. So let me write that, okay? So it's equal to big square root plus or minus, but I know it's positive. How do I know it's positive? 45 degrees is in quadrant 1, right? So instead of plus or minus, it's just positive. You don't need the plus, but I'm going to put it there anyway. I'm going to go 1 minus a cosine of 45 over a 1 plus cosine of 45. Okay. Now, let's go to the unit circle and let's evaluate. So cosine of 45 should be square root of 2 over 2, right? 45 degrees, cosine theta square root of 2 over 2. So I'm going to write this as square root of 1 minus square root of 2 over 2 all over 1 plus square root of 2 over 2, okay? Well, that's a pretty ugly looking answer. I mean, it's technically correct, but it's not going to be a very good answer for calculus. So what I'm going to do is change this into 2 over 2 and change this one into 2 over 2. So if I change them both into 2 over 2, I have a common denominator. Okay, you see that?
Wait, why can you not just cancel those out?
Oh, great question, Zoe. That'd be so nice if you could. But you have to subtract them before you can divide them, right? And let me give you a super easy, just plain old number example, okay? Real quick. 1 minus 5 over 1 plus 5, right? What's the answer?
46.
It is 4/6. Do you agree it's 4/6?
No, I don't know.
Well, you have to think about parentheses. They're not there, but they are there invisibly because you need the entire top to divide with the entire bottom. So what you get is really negative 4/6, right?
Mm-hmm.
Right? And you can try it on a calculator if you want to also, but it is definitely negative 4/6, okay? If you cancel the 5s, and put it back up then, 1 minus 5 over 1 plus 5, because 5, you get 12, you have an answer, okay?
But how come sometimes we can do that?
If it's multiplication, you can always cancel. If it's multiplication. But if it's add or subtract, you can't, because you need to be able to subtract them or add them before you divide, right? All right, keep going. All right, now I keep going from there. So I changed the 1s into 2 over 2 for a reason. Because what I want to do is be able to write this as, okay, I have a 2 minus the square root of 2 over 2, okay? Show it again. So I've got 2 minus square root of 2 over its common denominator of 2. And I'll do the same thing. I'll go 2 plus square root of 2 over here, all over its common denominator of 2. You guys see that?
Mm-hmm.
So we'll have a 2 plus a square root of 2 all over 2, okay? Okay, I got a fraction divided by a fraction, so let's invert multiply, okay? So I'm going to rewrite this as the big square root of 2 minus the square root of 2 over 2 times, flip it, right? Flip it, times 2 over 2 plus the square root of 2. Okay, now we can cancel. So you see why we can cancel the 2's? It's because it's over multiplication, right? So because it's over multiplication, we cancel, cancel. And then we get a weird answer of big square root of 2 minus the square root of 2 over 2 plus the square root of 2. And we're going to stop there. There are other ways. We could take it further, but that's far enough, okay? How am I doing? Okay. Okay, example 2. It's still a half angle. You see, if I took 5 pi 12ths, right? And that's the same thing as 5 pi 6 times 1/2, okay? First of all, before you even go further, you have to be able to see this. So if I take half of 5 pi 6, I get 5 pi 12ths. But you see that? So this is a half angle formula. It's really 5 pi 6 over 2. So the problem, and I'll put it right up here, is really sine of 5 pi 6 divided by 2. Now that is really weird, but the reason I'm writing it that way is because if I go to my formulas, okay, go to my formulas, I've got a half angle formula. Okay, here it is. Sine of an angle divided by 2. I got sine of an angle divided by 2. Okay, but 5 pi 6 divided by 2 is 5 pi 12ths. And the question we're trying to find is 5 pi 12ths, which is half of 5 pi 6. Have I confused you?
So that's the answer?
Well, what we got to do now is we've got to use a formula. So we're going to use this formula here, right? And in the formula I've got just theta, not half theta, but theta. So for us, the angle we want to use is 5 pi 6. So theta is 5 pi 6, which we have on the unit circle. Okay, that's a unit circle angle. Okay, so I'm going to use that in my formula. So my formula is, okay, sine of my half angle is going to be this one here. So we're going to go plus or minus square root of 1 minus cosine of 5 pi 6, because that's my angle, all over 2, all right? Okay, now this might be a little confusing for you. If you want to change these to degrees, it might help, okay? So 150 degrees, what's half of 150 degrees? 75, right? But I'm just going to do it in terms of radius. So, here's my angle. My original angle is 5 pi 12ths. That is half of, this is half of that. So 5 pi 12ths is half of 5 pi 6, and that's why we're going to use our half angle formula, okay? So 5 pi 6 is on the unit circle, right? So I'm going to go positive square root, because it is positive, 5 pi 6 for cosine. Actually, that's negative. That's negative. 5 pi 6 over there. So negative 1 minus, let's see, what's the cosine of 5 pi 6? Cosine of 5 pi 6, cosine, yep, minus square root of 3 over 2, all over 2. Awesome. Okay, double negative, right? And I'll change this to 2 over 2, so I'll get a common number. So I'm going to bring this over here just for room. So I get negative square root of 2 over 2 plus the square root of 3 over 2 all over 2. Okay, how am I doing? I have a common denominator and I'm going to invert and multiply. 2 over 1. So I'll rewrite this as negative square root of 2 plus the square root of 3 over 2 times a 1 over 2, right? Because I inverted and multiplied. So I'm almost done. Okay, I'm going to get negative square root of 2 plus the square root of 3 all over. I'm running out of room, so we'll say it. Square root of 4, right? You get 4, but what's the square root of 4? Plain old 2, so I took the square root away from that, okay? Thumbs up? Kind of weird, isn't it? Okay. Okay, return the page. Okay, example 2. Okay, this one's not too bad. This one's quite a bit easier. You guys won't mind this too badly. So, first of all, quadrant 3. When I see that, what do you normally want to do? When you see something about quadrant 3, let's draw a triangle, right? And I'm going to draw a triangle here, okay? Draw a right triangle. Tangent is the opposite over the adjacent, right? You guys agree with that? So my opposite is, here's my theta. Opposite is 8. My adjacent is 15. Actually, it's negative, isn't it? It really is negative. How do I know it's negative?
Because quadrant 3.
Yeah, smart girl. Now, I need the hypotenuse. So, let's go a squared plus b squared equals c squared, right? A squared plus b squared equals c squared. Negative 8 squared plus negative 15 squared equals c squared, right? See, I need to find the hypotenuse. That's what I'm working on right now. I'm going to have 64 plus 225 equals c squared. 289 equals c squared, but if I square root, that's just going to be 17. And that's just 17. Okay, 17. All right, there we go. We got 3 different problems. It's not hard though. So, the formula. Sine of theta over 2, it's going to be, in this case, a negative. It's got to be negative, so we're on quadrant 3, right? Negative square root of 1 minus cosine theta over 2. All right. Cosine of theta. We're not on the unit circle, but we've got a triangle, right? We're not on the unit circle at all, but we've got a triangle. So cosine is adjacent over hypotenuse, right? So it's going to be negative 15 17. So right here, we're going to write negative 15 17s, right? So we're going to go negative square root of 1 minus a negative 15 17ths all over 2. Okay, how am I doing? Double negative plus plus. Need a common denominator. So I'm going to make this into a 17 over 17. So I'm going to change the number 1 into a 17 over 17. And the reason I'm going to do that is because then I can add these two, right? I can add these two because they have common. So this was the number 1. But I changed the number 1 to 17 over 17 so I can add these, right?
Mm-hmm.
So I'm going to get negative square root 32 over 17. And I'm going to invert and multiply to save a step. You don't mind if I save a step. Times 1 over 2.
Wait, what step did you skip?
I skipped the invert and multiply. Because I really got a fraction divided by a fraction, so I invert and multiply.
Okay.
So you have to go 2 over 1 and get 1 over 2. Right? So because I don't want to, because it means just one more step, right?
Wait, but why is 17 plus 15?
17 plus 15 is 32.
Okay, never mind.
Now, you're doing good. You're doing good. Okay, so then, do you see anything? What do you see, Evan?
You can turn the 32 into a 16.
That's what I see also. So what Evan sees is you can cross reduce here and here. You guys see that cross reducing here and here? So you get a 16. So you get negative square root of 16 over 17, right? And then I can take the square root of 16, right? So then I get negative 4 over the square root of 17. I would take that answer, but I like to fix the problem with the problem, so I would probably better answer negative 4 square root of 17 over 17 is a better answer. When I fix the problem with the problem, so remember how we fixed the problem with the problem?
Mm-hmm.
I'm just going to multiply by square root of 17, square root of 17, right? And I get negative 4 square root of 17 over 17, right? And that's a better answer, okay? All right, now we got the other two to do, okay? Very similar, okay? Very similar, okay? So let's take a look at cosine. So I look at my formula. Cosine of theta over 2 is plus or minus square root of 1 plus cosine of theta over 2, okay? So I'm going to redo this problem again, but with the other formula. So I'm going to go, okay, it's going to equal negative, and it's negative because we're in quadrant 3, negative, and we're going to go a 1 plus cosine theta over 2. Okay, again, we're not on the unit circle, but we can get the cosine value from the triangle, right? Cosine is adjacent over hypotenuse, so it's negative 15/17. So we're going to get a negative square root of 1 minus adjacent over hypotenuse minus a negative 15. Hold on, I made a mistake. Plus. It was plus. The formula is plus. Plus is right there. A negative 15 over 17 divided by 2. Okay. Again, just to save room on the exact same step, I'll make that into 17 over 17. So if I make it into 17 over 17, I'll have a common denominator, right? You guys agree with that? I'm going to change that 1 into 17 over 17. So this is going to be a 17 over 17. So I'll have negative square root of, so 17 minus 15 is 2 over 17. Hang in there, Morgan. I know you guys are tired. Okay, 2 over 17, right? But divided by 2. So do you mind if I skip a step? Invert and multiply, right? Make it over 2 and invert and multiply to make it 1 over 2. See the steps I'm doing? So it's just basic fraction stuff, right? So then I'll do the same thing here. This is like 2 over 1, so our invert and multiply make it 1 over 2. And hopefully you guys see what I'm going to do. What's the next step?
Cancel.
Cancel. The 2 is boom to. I get negative square root of 1 over 17, right? Which I would take, but a better answer would be negative square root of 17 over 17 when you fix the problem with the problem, right? What do you think? One more tangent. Okay. All right. That formula. Let's see if I use my notes. That's the 1 minus cosine theta over 1 plus cosine theta. Okay, so negative square root of 1 plus, 1 minus, my bad, 1 minus cosine theta over 1 plus cosine theta, okay? Right out of my notes. Boom, boom, okay, got it? So, again, cosine, we're not on the unit circle, but we have a triangle, so I can get it. Big square root of 1 minus. So cosine is adjacent over hypotenuse, so it's 1 minus a negative 15 over 17, all over 1 plus a negative 15 over 17, okay? Cosine, right? Cosine is adjacent over hypotenuse, so negative 15 17ths. Negative 15 over 17, okay? How am I doing? 17 17ths, right? As a common denominator. We change this to 17 17ths, double plus. 17 over 17ths here, right? That's the thing there, okay? So I'm going to, first of all, make this a plus, right? Double negative, right? And I'll go and make this a 17 over 17. I'll make this a 17 over 17, so I have a common denominator, okay? So big, ugly square root of 17 plus 15 is 32 over 17 divided by 15 plus a negative 17 plus a negative 15 is a positive 2 over 17. Okay, now what do you think we're going to do? What are we going to do?
Invert.
Yeah, invert and multiply. Okay, so I've got a 32 17ths times a 17 over 2. What do you see? This is getting easy.
Cancel.
Cancel. And what do you get here? Negative square root of 16, which is negative 4. Cool. Okay, we can do this. Okay, last but not least. Okay? All right. Now, we've got Tangent squared. So there is, let's go back to your identity, okay? Hold on, let me get back to the identity I want. Okay. This is tangent of theta over 2, okay? If I square both sides, I'll get tangent squared of regular old theta is equal to, and that's one of the identities I didn't give you, but it's in the book. It's equal to 1 minus cosine theta over 1 plus cosine theta, okay? So that identity becomes that, okay? So we're going to have a 1 minus a cosine theta over a 1 plus cosine theta times sine of theta. And if I multiply that through, I'm just left with a sine theta plus a, minus a sine theta cosine theta over 1 plus cosine theta, and we've gotten rid of the square, okay? Okay? How am I doing? Okay, that's all I got. We got lots of time